All right, guys, so this is the video for section 5.4, so get your 5.4 notes out, and I'm just going to lecture on this like I would any other lecture in class. Okay, in section 5.4, we're going to talk about equilateral and isosceles triangles and some of the properties that they hold. Okay, so as a review, an equilateral triangle is simply a triangle with three congruent sides, so all sides are the same length. And then an isosceles triangle is a triangle with two congruent sides. Okay, so let's first talk about the anatomy of an isosceles triangle. Okay, so notice on an isosceles triangle we have the two congruent sides. Okay, that's what makes it isosceles. So in this case, well, in all cases, the two congruent sides are called the legs. So the two congruent sides of an isosceles triangle. Okay, so two of the sides are the legs, and those are the two congruent sides. And then the third side that's not congruent to the other one, it's called the base. So the third side of a triangle that is not congruent to any other side is called the base. Okay, now the vertex angle would be right here. Okay, it's where the two legs come together. So it's the angle formed by the legs of an isosceles triangle. And then you have two more angles along the base, and these are called the base angles. So it's the two angles along the base of an isosceles triangle. Okay, and that's kind of the anatomy or the makeup of the isosceles triangle. Okay, so that brings us to the base angles theorem. Okay, now this theorem tells me that if two sides of a triangle are congruent, so anytime I have an isosceles triangle, okay, then the opposite angles of them are going to be congruent too. Okay, so in this triangle, if this side is congruent to this side, okay, well, the opposite angles, so that means this angle would be congruent to this angle. So these two angles would have to be congruent. Okay, so the thing you need to know is in a triangle, if you have two congruent sides, you have two congruent angles. Okay, always. That will always be true for every triangle. Okay, and the angles opposite of the congruent sides are the two angles that are congruent. So if I look at example 1 here, it says in triangle DEF, I'm told that DF, which is right here, is congruent to DE. Okay, so these two sides are congruent. Okay, so because those sides are congruent, because I have two congruent sides, I'm going to have two congruent angles. And the two angles that are congruent are going to be the angles opposite of the sides that I know are congruent. So that would be this angle here and this angle here. So I could say that angle F is congruent to angle E. All right, base angles converse theorem. Okay, now remember the converse is when I flip the hypothesis and the conclusion. So this basically tells me that if I know two angles are congruent, okay, that would mean we're going to have two congruent sides. So two congruent angles means that I have two congruent sides. Okay, and the way I know which sides are congruent, once again, it's the opposite side and the opposite side. So in this case, AB would be congruent to AC. Okay, so if I look at example 2, okay, it says HG is congruent to HK. Okay, so basically those are two sides of this triangle right there. So if those two sides are congruent, remember, I'm only looking at this triangle here, that means the opposite angles would also have to be congruent. Okay, so that would mean that angle G is congruent to angle HKG. Okay, and remember, when you call this angle, you have to use 3 letters. And the reason that is because if I just call it angle K, well, you don't know if you're talking about this angle K or this angle K right here. So make sure you use 3. But that would mean these two angles are congruent. All right, so I'm going to erase kind of what I have so it doesn't confuse us on B. Okay, but on B it tells me that angle KHJ, so KHJ, so this angle here, well, that angle there is congruent to KJH, which is this angle here. Okay, well notice those are two angles of this triangle here. Okay, so I'm just going to look at this triangle. I don't care about the one on the left. So if those two angles are congruent, we have two congruent angles, which means I have two congruent sides, and the two sides that are going to be congruent are opposite of those two angles. Okay, so that would just mean that JK, so side JK, is congruent to side HK. All right, so that brings us to the corollary of the base angle theorem and the corollary of the base angle converse theorem. And basically what this theorem tells us is that three congruent sides means three congruent angles. Okay, and then also three congruent angles tells us we have three congruent sides. Okay, so in other words, every equilateral triangle is also equiangular, and every equiangular triangle is also equilateral. All right, so let's look at example 3. Okay, it says example 3, find the measure of angle P, the measure of angle Q, and the measure of angle R. Okay, well, if I look at this triangle, guys, it shows me that all three of these sides are congruent. And I know they're congruent because they have the same markings on them. Okay, so remember, if I have three congruent sides, that means I have three congruent angles. Okay, so because this has three congruent sides, that means this angle, and this angle are all going to be the same. Okay, so if I call each one of these x degrees, okay, we know that all three of these have to add up to 180. So x plus x plus x equals 180, or 3x equals 180. So if I divide 180 by 3, you would get that x equals 60. Okay, so that means that angle P is 60 degrees, angle R is 60 degrees, and angle Q is also 60 degrees. And once again, that's because if I know all the sides are congruent, I know all the angles have to be congruent as well. Okay, now let's look at example 4. Okay, it says find the length of ST, and ST is right here. Okay, well notice in this triangle, all three of these angles have the same markings, which means that all three of these angles are equal. Okay, and like I told you before, if I have three congruent angles, that means that I have to have three congruent sides. Okay, so because this triangle has all three angles that are the same measure, that means each one of these sides are the same length. Okay, well, if I know this side is 5, that means this has to be 5 and this has to be 5 as well. So I could say that ST is equal to 5. Okay, let's look at example 5 now. It says use the diagram for the following. You want to solve for x and then solve for y. All right, well notice my x is right here. Okay. But I'm actually going to solve for y first, just because I have more information that allows me to solve for y first. Okay, so if I take a look at this triangle right here, okay, notice that this angle, and this angle all have the same markings, okay, which means that it's an equiangular triangle. And we should know by now that if it's equiangular, if all three angles are equal, that means all three sides are going to be equal as well, which means this side's going to be 4 and this side's going to be 4. Okay, so y equals 4. That's the easiest thing to do. Okay, then I can go and solve for x. Okay, well, x is talking about this side length. So LM is x plus 1. Okay, so really what I'm concerned with is this triangle, okay, because that's what LM is a part of, is that triangle. Okay, so if I know on this green triangle, if I look here, it shows me this angle here and this angle here are equal. Okay, so remember, two equal angles, that means I have two equal sides. So that would mean the opposite sides from these angles. So this side and this side would have to be equal. Okay, well, because when I solve for y, I found this is 4, that means this has to be 4 as well. So to solve for x, I can say x plus 1 equals 4. Subtract 1 on both sides, I can find that x is equal to 3. So x is equal to 3, and then y is equal to 4. All right, so here for our last example, okay, I want you to pause this video. I want you to try to find x and y on your own. And then when you're done finding x or y, come back and we'll go over it. But try this one on your own first. All right, so hopefully you've tried this one out. But if I look at this, I'm going to solve for x first. Okay, because when I look at x, it's an angle of this triangle right here. Okay, and I notice that each of the side lengths of this triangle have 2 hash marks. Okay, that tells me that all 3 of these angles are equal. Or sorry, that all 3 of these sides are equal. And we have talked about that if we have 3 congruent sides, that means we would have 3 congruent angles. Okay, so that means this angle has to be equal to this angle, which has to be equal to this angle. Okay, so that means this has to be x and this has to be x. So if I say x plus x plus x, remember all through the triangles have to add up to 180. So 3x is 180. Divide both sides by 3. I get x is 60. And that's my x. Okay, well, if this is 60, this is 60 degrees, this is 60 degrees. Okay, now if I move over to y, I see that y is a part of this triangle on the left. Okay, so if this here is a 90-degree angle and this part 60, that means this little part here has to be 90 minus 60, which is 30 degrees. Okay, so this here is 30 degrees. Let me go ahead and draw this out a little bit easier. Ooh, let me try that again. So this is y degrees. We know this side and this side are equal. And I just found that this is equal to 30. Okay. Now, when I have 2 congruent sides, which I do here, when I have 2 congruent sides here, that means I have 2 congruent angles. So that means this angle and this angle here have to be the same, which means this is 30 degrees. Okay, now I know these 3 have to add up to 180. So 30 plus 30 plus y is equal to 180. So just 60 plus y is 180. And if I subtract both sides by 60, I get my y is equal to 120.